then just now I'm doing arch effect, right? Yeah, arch effect. So how are we going to further? So I'd like to go back to my e-views here. Then what is this? This kata, right? Where's my model? Wait, my models. Copy, then go to e-views, and then go to the quick estimate equation, then paste. Okay, yes. So now I'd like to start with the arch model. So I would like to go to estimate, then the method here, you scroll down, there is an arch, right? You can see the least square, choose state least square, GMM, L, I, N, L, a lot of method, right? Yeah, there are a lot of method here. So now I would like to focus on the auto-regressive conditional control scarcity. So still remember the last item, right? There is a ARDL, right? Yeah, it's an ARDL. So I think you spend 1 day, right? Yeah, 1 day. So to work on that, so I give you 1 day to go through the video, right? Yeah, videos, and then go through the files. So I hope you're okay, right? The ARDL models. So now, actually no need to give so long answer, right? Just within the box, right? Some of you extend the box until 11 to 20 pages. So actually I'm supposed to have a on-the-spot exam, then easy, right? Then you just fill up in a hard copy just within the box for 2 marks. But turn out that is a few pages for one section. It means that so end up you have more than 12, 13 pages for one structural question. So I need more time to go through that. So last time I used the student to fill up just within the box, just short answer enough. But maybe it's an open book, a lot of things to copy and paste inside, right? Maybe use the AI. This one, remember that plagiarized work will not be accepted. So remember that point, because as noted in the instruction, plagiarized work will not be accepted. So just a very simple one, right? So give a definition, that's only, right? So make it simple to score to answer the question. Then that's why I don't know why you all give 12 to 13, 14, 15 pages. So just like reading the textbook already. So no worry about that. But for the analysis part, it's quite short. So analysis part, right? Just one sentence only. Maybe because it's practicals, right? So only come out one output, so only one section. Easy, right? Next time maybe we'll have much more on the practical part rather than the theory part, right? Practical part is much more precise, give you a precise direction. But the theory part may be a lot of reference book, so a lot of things. So once to get to the key point, right, it's very hard to mark for the theory part. Don't worry about that. So now we go to the arch. So method is arch, right? Yeah. So equation estimation. So now a little different compared to the ARDL model. ARDL model, as we are aware that because of the matrix I1, I0, so we need to use the methods to accommodate the matrix of I1, I0. So we use the ARDL models instead of Johanson. Johanson is a conventional quantification test, just useful for the I1 variables. So ARDL come in, then that's why we have a short run, long run models. Short run, long run, then we can use the bound test to test for the long run regression, and then we have a short run regression as well. So for the short run, we have an ECT. So that's one for ARDL models. Then now we further to the volatility model. Is used to see when there is an arch effect. So how are we going to handle? If we not tackle this arch effect, there is a problem in the parameter as well as the standard error and the test statistic. So you see your mean equation. In the volatility models, there are two parts. One is the mean equation, the other one is the variance equation, what we call as the variance model. So in the mean equation is the univariate models, right? So we only have one series, univariate series. So it's the changes in my for my finance data set, and then lag for my finance data set is an AR1 model. So here is in the right hand side here is the arch n, right? Arch n is referred to the later on if you have a mean, then we will use this function. But now about my variance. My variance here is a distribution classification. So model here. So here we have a gush, T gush. When you scroll down, actually a lot of things. So actually we also have a E gush, power gush, and then gush 11. I think this is I think fraction, yeah. Free gush, and also another one is FIE gush 11. So a lot of gush family actually, gush model, gush family. But we just discuss on the first two only, gush, T gush, and the E gush. So now I want to show you how to run this, what we say the ARCH model with the P component is 0. You set the P equals to 0 because still remember we just focus for the ARCH model just the Q only, right? So Q is 1, so it's a Q set equals to 1, and the threshold is 0, and the gush is 0. Gush here refer to the P, right? So this value only appear when you have the what we say the gush effect. So you want to capture the gush effect, then you set here 1. So now you will first start with the 1 here, gush, ARCH 1. Then you will click OK, click OK. So this is my how we say the volatility model with the mean equation and the variance equation. So maybe I copy and then paste this one, make it bigger, right? Yeah. So I go to the here. Oh. Okay, forget already. Okay. So this is my mean equation. So this is my mean equation, and this is my variance equation. So this is how we model the variance equation. So the variance equation, you take a look your variance, the dependent variable here actually is a sigma power of 2. Another way to write it is a H, right? H is a variance equation, is a H, is how we model the residual. How we model the residual for the mean equation. So we have the residual lag power of 2. So this is a ARCH 1 model. So given us the ARCH 1 model here, this coefficient and it is significant. So there is an ARCH effect, right? There is an ARCH effect here. So let's see how we can explain this term, right? Still remember the one term here. Yeah. ARCH. Yeah. So this is the ARCH, right? This is ARCH, correct? So this is a dependent variable, is a variance for the error terms, is my dependent variable. And my intercept is this one, my constant, and my residual power of 2 lag 1 period. Because I just put the P, I just put my P equals to 0, Q equals to 1, Q equals to 1. So Q equals to 1 here, just 1. So T minus 1. So I just model my variance for the error term is depends on is allowed to be influenced by the lag for the error term squared. Only one period. So this is the thing here. Only one period. So what happened? How are you going to write your models? How are you going to write? So I will report my variance model. So my mean equation will be my changes, right? Yeah, changes for my log for my price here is time t, and then constant. Constant is negative 0.00027, and then plus 0.187. Have to be consistent now, but because of the space, so I just put here, and then changes in the known for the ft minus 1. So this is time t. So this is a mean equation, okay? This is my structural model, mean equation. And how about my variance equation? So variance equation. So, because still remember in another way to write in the sigma power of 2 times t, right, is ht. H times t, right? So actually equals to the constant is 0.0002, and then plus the 0.8132 for decimal. Then how to write this residual minus 1 power of 2? So you can refer back to here. Actually, we can written it as residual t, power of 2, t minus 1. If you want to make it consistent, you can use as u, right? U also can. Just follow this symbol. It's absolute. Power of 2, t minus 1. So this refers to the variance for your residue. You got a cat, right? So like this. So if the question asks you to write down the variance equation, so this is the way for us to present my variance equation, and this is the way for me to present my mean equation. Okay? So actually this is for the arch 1 model, arch 1. So it's an arch A or CH 1, arch 1, arch 1 model. So now, we talk about the arch 1 model. So how we going to, then you say, I want to look at the volatility, right? I want to look at the volatility. How are you going to write the volatility? Let's say write like draw the volatility, right? So you can go to the e-views here. Then you got students, your friend will ask, is it this one is a final, is it this one is a good model? Because as we are aware, the arch 1, because of the, we just impose the P equals to, Q equals to 1, right? Yeah, Q equals to 1. And then I just want to use the simple model, right? Arch 1 model. Is it this model is a best model? So how we going to diagnose it? Because the normal practice in this field is we diagnose the model when the model no longer has the arch effect. Means that the final model no arch effect, so that is the best volatility model. So we can go to the view here and diagnostic for the residue. Yeah, we can go to the diagnostic for the residue, and then you can check for the arch LM test. We can go to check on the arch LM test. Then for the arch, just now I got test 2, right? So you can continue with the 2, then click OK. Yeah, 24.6. So we understand it's the arch test, right? So focus on the observation and the R square. Then p-value significant. So still significant, right? Still got arch. So how about 4? You can go to view again. Go to the diagnostic for the residue. Click the arch again, arch test again, and then click on 4. And click OK. 38. Still significant. Still got arch effect. How? Go to view again, and then diagnostic for the residue, and then arch, and then you check for 10. Click again. 132. The test statistic become bigger and bigger and bigger, right? So actually, it still got arch effect, right? Even though you already model for the arch already. So how about autocorrelation? You can go to the view, diagnostic for the residue, and then you can click on the correlogram Q statistic. Check for the autocorrelation. Oh my goodness, you look at the Q statistic here. Because we understand that this correlogram of the standardized residue is used to test the serial correlation, right? So remember in our EMH chapter, we can use this Q statistic to check whether there is a serial correlation or not, right? But now we not concentrate on the EMH whole or not whole. We are concentrate whether there is a serial correlation or not. So highly significant up to like 36, right? So how about the standardized version? You can go to the correlogram square residue. So here, well, Q statistic also highly significant. Oh, so actually it's come up with a signal that actually this model is not appropriate for you to model the what we say the volatility series, the risk series. So by the way, you can go to take a look, right, the volatility before we go to the gauge. So how we can see the gauge, see the what we say the series, the risk. Because when you click on the return, right, you go to the view here. This is my return, right? Now, just click OK. So this is my return series. Am I right? This is a return for my what we say the return for the series, the return. So I want to see the risk. I want to see the risk. So I go to my just now my equation, right? Oh, this is my equation. Gone already, right? No problem. For this mean copy. Image. This here. Okay. I can go to view. Okay, this is not. This is the display. I want the arch. Right? P equal to 0. I want the arch model. This is my arch model. Then I go to view, and then I can go to the Gauss graph. Right? I can go to the Gauss graph to see my what we say the volatility series, or we can say as a risk, the risk. So there are three things here. There are two things. One is the conditional standard deviation. The other one is conditional variance. So what is the variance series? The other one is the standard deviation, standard error. So then you ask which one is better. One is the without the square root, one is the after the square root, right? So you can see variance. Oh, this is my risk. So up to, because I model 1,000 15 something, so in 1,500 something observation here. So you see the risk is high a little bit here, then a little bit high during this period, right? But it's normal, it's nothing, no risk in this period. So then you say which period is which period? Is you have a time series data, because this is just observation. If you have a time profile, time chain, so you can see the risk during that particular date. Am I right? You can use the top growth series as an example to model the arch model, Gauss model, and E-Gauss. You can see the return for this top growth, the risk for this return for the top growth, right? You can see during the particular what is the risk. So the risk during this period is 1102 is 0.017. So you can see the particular risk during this period. Then so how about if you go to the Gauss graph, right? Standard deviation. Yeah, because it's different, right? Because the square root of the variance becomes standard deviation, right? So you can see the standard deviation. There is a little bit different story compared to the variance series, the conditional variance just now. So actually, what happened in this field in the finance? People would like to check actually what happening during this particular period, and what happened during this particular period, right? And then what happened during this particular period. Actually, what leads to have a high volatility during this period? You mean the risk for this stock price actually quite high during this particular period. Yeah. So actually, what's so important with this information? Still remember the motivation to estimate the volatility models. So we can, as an investor, we can see, okay, we have a high risk here, but low risk here, right? Then we also have a high risk here. So it means that there are several uncertain periods during these three periods. I can classify into four 1, 2, 3, 4, right? Or three right? 1, 2, 3. So as an investor, if you are risk level, are you going to invest during these three periods? Yeah, right, because it's uncertain, right? Wow, you can earn a lot, right? If you are risk level. How about risk averse? I'm not going to invest, right? I need to have a very safe return, so I don't want to invest this particular period. Actually, what other information you can obtain? We can use this volatility model to predict the risk. We can predict the risk also. What is the next period of risk? So we can use this volatility model to predict the future risk as well. So we can use what means that predict the future risk or predict the uncertainty in this series. So this is the objective for us to model, but on the condition that just now we also aware, right? This model actually got limitation. So still have arch effect, right? So actually then you say, then when we only can get the no arch effect model, it means that eventually your model passed the arch test, and no autocorrelation. Then that's the final model. That's the model's one. So before we move forward, you can go to view again, right? Go to view, diagnostic for the residual, right? Actually, still got normality test, right? You can check for normality test. You go to view, diagnostic for the residual, and check for the normality. Once you click on the normality, then you observe that the dark barrel statistic highly significant. So actually, what is the purpose for Jagdara statistic? It's used to test for the normality of your model, of your residual. It's actually check for your residual, and you can see here the series here actually check for the residual. So now this result shows you that the Jagdara statistic shows that these are two scholars, Jagdara come up with a statistic. The test is used to check whether the series is follow the normal distribution or not. So as we are aware, now your model cannot pass the GASH, right? Cannot pass the ASH test, has a heat cross scarcity. Then I'm sure that the normality assumption not hold, right? Normality assumption hold only when the mean for the residual equals to 0 and the variance constant. But now the variance not constant because they still have an ASH effect. So that's why you see the p-value here higher significant as well. So this is the problems with your what we say volatility models. Then you say, can I take up this volatility series? Can you take up? How to take up? You can go to prop. You can go to prop and then make your GASH variance series. You can take it out. Why want to take it out? Because some of you might like to plot, right? Might like to generate this GASH series to see the time profile. What data point, where is the risk? What data point, where is the risk, right? Because this is the second order of the data set, not the first order. It's the second order. So you can go to the generator for the GASH. So actually this is ASH, right? This is ASH. Then you go to the ASH. Then you click OK. So you can see instead of the graph, then you have a series of the this ASH volatility series, a series of the volatility series. So you can see how when it's a high one, right? Because I estimate up to 1548 only. So if you estimate up to 2000, then you can get others data point as well. But I just focus on the up to 1548. So these are the data series. Okay. So now, trying to say, because of this limitation in the GASH, right, about the how to determine the P, how to determine the Q, right? So now there is extension for the, because next extension for this model, so you can go to the, let me see, book file. Where's my model? This 13 is really, B, piece, arch, 0, right? Yeah. So now, let me show you the difference between the ASH, GASH, and traditional first. Then we go back to the theory. If you go to the GASH one, right, it means that actually you're estimating the GASH model. So what is the difference between ASH and GASH? Let me show you the GASH first. GASH, this one. So the GASH model. So the difference between the ASH and GASH, right? The GASH not only the lag for the error term, also got the lag for the variance of the error term. Lag for the errors of these error terms. So it's a generalized for this GASH. It's proposed by this Borisov. So now, how the e-views work, you can see. So not only the lag for the residual, lag power of 2 for the residual, also got the GASH here, GASH effect. So GASH effect. So actually, what is the purpose for this GASH? We can test. So if you go through the slide later, you can test for the whether there is a GASH effect or not. Yeah. Actually, we have an ASH term and a GASH term now. Normally in the EVs here, whether it's an ASH effect or GASH effect. So in our result, both also significant. Both also significant. So let's see how the, just now I should save the series, right? So let's see how the ASH LM test, ASH effect. Maybe I start with 4, then set. Oh, now no more ASH effect, right? Yeah, no more ASH effect. When I accommodate this GASH effect inside, so no more ASH effect when I test for the ASH 4. arch as order 4. It's not significant, 0.6125. So how about if I test for the higher order, let's say 10. Also not significant, right? 0.7745. Also not significant. How about 2? Because now I test 2, 4, 10, right? 2, 4, 10. So arch, let's test for 2. Also not significant, 0.8. So what can I say? So you also can take a look the when we take a look the what we say this correlation square, right? Let's see. Oh, when I test for autocorrelation, also not significant. So this model, Gash actually is better than the arch, right? Yeah, because when I take into account the limitation in the arch, when I take into account the Gash generalized by using the generalized Gash, so when I model my variance for the residual, but include not only the lag for the power 2 residual, also include the variance for these error terms, make my model much more something like the residual is actually, the variance for the residual actually is appropriate accommodative compared to the previous model. So let's take a look at the volatility series. Go to the Gash graph. Let's say I go to the standard deviation. Ooh, so is it now? Then you say, right? It's not like same, right? Like just now also got a very high down during this period. 1, 2, 3, right? Then I say 1, 2, 3. Also same, right? Different meaning. Am I right? It will become a different meaning because the series itself, even though the pattern almost same, but the series you can compare the value. So now 0.07 something, right? But now it's a little bit high, right? 0.14 here. So it's a little bit will give you more information because this model is much more valid because it's generated from the Gash model instead of arch. So now, so how I can get this series? Again, you can generate, right? You can go to the plot and then match the Gash variance series. Again, this is Gash lah. Then you click OK. This is my Gash series. So in my word file here, I got arch, I got Gash. Then how about another one more model? Before we go to theory, because I understand that you are taking go back home, right? Before hours. So I think I need to I will discuss the theory in my lecture later because I will discuss again the theory during the recorded video for the next week together the variance at risk. So today we will much focus on show you the practical part. Just want you to break you to see the practical part. So another model is a Gash inmate. Gash inmate. If you want to study the risk on the return, so you use the volatility model to generate the risk. If I want to study the risk on the return, so this is my return, right? So the risk inside your main model, the risk on the return. So how are we going to study? I can use the Gash in mean model. Gash in mean model. So I can, after I estimate this model, I get the risk series. Because after you estimate the model, I can get the risk series. So after I get the risk series, I put inside my mean model. So we call it as a Gash in mean. Gash in mean. We also can have an arch in mean, right? But my arch model not good, right? My arch model got arch effect, so I don't want to use my arch model. Now I would like to use my Gash model. I want to study the Gash in mean. I want to see whether the risk is it got any impact on the return or not. So is it useful information? Yeah, I want to see is it the risk uncertainty in the stock price going to impact the return on the stock price or not, on that particular stock price or not. So I want to see this risk. So how are you going to achieve that? Again, my model disappear, right? Estimate again. Each. I come here, we go to copy, and I go to image here, paste. Oh, sorry, I should go to estimate the arch, right? Arch. Now, it's a 1, 1, right? That actually is a mean. Gash in mean. So, in one of the lecture slides, there are 3 ways to model this risk. Either you can go to the standard deviation, variance, or the log variance. But in the literature, normally they will incorporate the standard deviation. Standard deviation. So yeah, standard deviation. I will upload the paper for you to see the difference. Actually, in the literature they include, oh, they want to test sensitivity, right? They include 1, 2, 3 as a proxy for this risk in your mean equation. But widely used is a standard deviation because widely used, right? So people will just follow. But there is the explanation just same. Just the how you measure the risk, right? They use the standard deviation instead of variance. So standard deviation as a proxy for the uncertainty. So you click OK. So as you observe, there is a standard deviation of this series, risk series inside this equation, in your mean equation. Again, this is your mean equation, right? This is your variance equation. So this is your variance, this is your mean. So, but what happened? Is it the risk got any impact on the return? No, because the risk now is not significant. The risk is not significant in the mean equation, 0.35, and the risk is positive. So it means that higher the risk, higher the return, but not significant. Higher the risk, higher the return. Is it a leverage effect? So remember the leverage effect we discussed just now? Is it the higher the return, the risk also going to increase, or the other way around? So you check back the statement just now, the leverage effect. So it's insignificant. So how about if I change to the mean, I use the variance? So what happened? Oh, also positive, still insignificant. Then some study, they want to try right to see the log for the variance, so what happened? Yeah, still the difference. The log, because why log? If you use the log for these variables, right, the explanation will be different already, right? Because it's talked about a functional form. Once you log, when you explain, you have to use the explanation, different explanation. So also insignificant. So this is the judgment one. So maybe you can say, okay, is this one model suffering from the arch effect? You still can use go to the view here, and then diagnostic to check it, to check for the arch. To check for the arch, perhaps you can start with the 4 and check. So, okay, no arch effect. How about other? Then you say, why you want to check again? Because you did a different model already, right? So how about normality? Oh, how come normality is significant? Yeah. But now we can say that this normality actually, what I can say that when you deal with the high frequency data, so even though your model already get rid from this autocorrelation and already get rid from this Heathrow scarcity, but normality sometimes still cannot pass because we are dealing with a very high frequency. High frequency data, there are a lot of information inside the time series. It's very volatile, and we can say there is a term in this finance, it's called outliers. There are a lot of outliers, right? Because we are dealing with the 1,000 over data. So if you have a project paper, when you deal with the daily data, you can see there are a lot of information fluctuation, and this data point, this fluctuation data point, or we can say outlier, will make our normality test fail. Yeah. But I already checked for my arch effect, I already checked for this arch, I already checked for this autocorrelation is passed. But only the thing is the normality. So what the people in this field, they will accommodate this volatility, but they just report the result because the models already passed the autocorrelation and Heathrow scarcity. But normality, because we deal with the 1,000 over data, it's very hard to pass the diagnostic check. But if you use a lower frequency like the what we say annual data set or quarterly, normally is where you can get rid from this problem for this normality test. So then you say you want to plot this gauge and arch, right? So you can plot arch and gauge. You can plot the arch and gauge together to see the difference. You can plot them as a group and to see the difference for these two series together, right? I think in a single stack in a single graph, or if you stack in a single graph, what happens? Oh my goodness, you don't see anything, right? So perfect. One in the right axis, as giving this one arch on the right hand side. Yeah. So this is the difference. You can see here, right? So even though this is the arch model, right? And this is from the Gash model. So if the question asks you what you can observe from this series, maybe if you plot, you already estimate this model, right? Maybe in your during your if you want to estimate, for example, for your company exchange rate, right? Sometimes exchange also can study the risk, right? Exchange rate risk. You also can use this institution risk. So you can use this kind of model to model the risk series. So if your policymaker asks you, can you tell me what happened during this period? Why so the series something like abnormal, right? So high. Actually, it shows that there is a high risk during this period. It's a high risk, right? Suddenly jump. Actually, something happened, right? Something happened. It might be due to, if you deal with the time profile, it's easier. Maybe it's due to the something like because of the bad news coming, right? Bad news or global financial crisis or the COVID-19 crisis during this period. Then the stock market actually fluctuated a lot compared to the past. So you can explain a bit compared to the past. So there's a little bit fluctuation here also, maybe because of the internal problems. So that's the things. I think okay, good for today. So I think we need to I continue this one next week lah. Next week don't have class, right? Next week don't have class, but I will do the recording for this topic. Continue for the Gash, start from the end, continue for the Gash model and also the value at risk and estimation. So you got a data set, right? Yeah, you got a data set already in your spectrum. So you can practice. You can practice that while we doing the watch the recorded lecture, right? So by the way, you can go through the references here, lah. For example, you click on the books, right? Actually, this is a book is from the textbook, but this is just a chapter focused on the volatility. So you can have a better understanding now, go through this textbook. And also by Angel, right? Angel Gash 101 by Angel. You can click on this one, yeah. So you can see how you can apply the Arch and Gash model in the applied econometric. So it will show you the Dow Jones, the rate, and then the portfolio. Then see how they report the result lah. Normally, if you say what is the guideline, right, for your project paper, let's say you want to study about the Gash model in your project paper, because so far we cover the several models, right, in the finance, like the EMH, right, EMH, to test whether EMH hold or not hold. So you can use the unit test, or you want to use the several tests using the Excel sheet we discussed last time. If you want to study about the CAPM, like what we question about the structural tool in our midterm exam, right? So you can take a look, you can replicate the models and then use a different type of data set, then reanalyze the result. So expected the format like the guideline, so you can report the result like data set, right? Like you can report the data description, then about the test for the this one, the autocorrection, the Q, right? Q statistic, see whether the autocorrection or not, and Gash 1-1. Yeah. So the variance equation. So we have the Arch effect, Gash effect, and then the p-value together lah. So you can see how the author explain, right? Explain the result, right? And also this one also got value at risk lah. Then you compare value at risk. Then you can see you can put the return and the value at and the risk together in one graph also. So depends on your creativity lah. And extension, you can extend to the eGash. Another one more model, right? Another one more model is the eGash model. So exponential Gash. But that one I think should show you next week lah, right? During the next week class. How to proceed with the eGash also. Okay? I think that's all only for today. I think some of you might have a question right to ask. So that's all only. See you all next week online, right? Yeah. Not during the lecture. You can join outside the lecture, right? Because it's a late recorded lecture. So you can watch the video during the next week class. But we're going to meet on 2nd January. Right? I confirm with the school already, 2nd January, no holiday already. So good. I said so good, right? 2nd January, no holiday. So meet you next year, yeah? I will meet you next year, 2nd January, physical. But next week is an online class. So please log in the Spectrum, record your own attendance, and then record the lecture. So any question? Any question about your group assignment? Because some of you have a group assignment question, right? Actually.
Okay.